This video I'll be demonstrating you the test for bismuth ions. So we need, this is the mixture in which we will test for bismuth ions. We take some of the mixture in a clean and dry test tube. Now we have to prepare the original solution. So over here I am preparing original solution of the mixture in dilute hydrochloric acid. So now we have prepared the OS. You can see that the solution is green in color. That is due to the other ions present inside the mixture such as chromium and cobalt. But bismuth salts are generally colorless. So now we have prepared the OS, and you know that we have added already dilute HCl in excess. So that means, and we have obtained a clear solution. There is no PPT inside this solution. That means there is absence of group 1. So now we will pass H2S gas in this OS to test for group 2. So over here I am preparing H2S by adding HCl to iron sulfide. And passing it through the OS through a delivery tube. You can see for more visual effects, perform this in a beaker, a small beaker. So over here I am taking a beaker. In that I am adding some water, and then I am dilute the contents. You can see already the PPT has started forming, a black PPT, which indicates the presence of group 2. Now you can see that a black PPT is formed. We will filter this PPT. So I filtered that PPT, and on filtering you can see that this is the black PPT we have obtained. Now our first step is to take out this PPT. Now transfer this PPT into a test tube. Now our first step is to dissolve the PPT in yellow ammonium sulfide solution at 60 degrees Celsius. But I know that group 2B is absent, which is tin, arsenic and antimony. That's why I am skipping that step. Otherwise we have to dissolve it in yellow ammonium sulfide so that group 2 sulfides would separate. But since I know that they are absent, I am skipping yellow ammonium sulfide step. Okay. So now after you have dissolved it in a yellow ammonium sulfide, filter it, and to the residue, now suppose that this is the residue, add nitric acid, 50% nitric acid, and try to dissolve it by heating. Bismuth is in group 2A, that is the copper group. That's why it is not affected by yellow ammonium sulfide solution and stays as a residue on the filter paper. Keep on boiling. If the precipitate still exists, you can add more of the nitric acid. On boiling, the precipitate dissolves, and you can see that there is a yellow PPT inside the test tube, which is due to the presence of sulfur. Now it's time to filter this solution. Filter this solution into a test tube. Now to this solution, add ammonium hydroxide in excess. You can see that a white PPT is formed of bismuth trihydroxide. Add ammonium hydroxide solution in excess. And then filter the solution. Now this filtrate contains, if cadmium would be present, then cadmium would be present in this filtrate. If copper would be present, the filtrate would be of blue color. Here copper and cadmium are absent. Therefore, I am discarding away this filtrate. Now you can see that we have got a white PPT of bismuth hydroxide in this funnel. So we have to dissolve this PPT in minimum amount of dilute HCl. So what I will do, I will add directly dilute HCl to this precipitate and collect the filtrate inside a test tube. So now this is our bismuth chloride solution. Now take this filtrate in a test tube. Take a small amount of a filtrate and dilute it with large amount of water. See, on dilution, you see a white turbidity inside water. This is due to the precipitation of bismuth oxychloride. This is the conformity test for bismuth ions. You can see that on dilution a white turbidity is obtained. You can also use a beaker or a larger test tube like a boiling tube to transfer these contents and then dilute it with water.